So hyperbolas are these wedges of the cone where we cut perpendicular to the base, so we get two little U shapes here, top and bottom, or sometimes in our class they're going to go side to side. You can fill this in at the top of the page. I don't have a great example of why this is important. I know they use this technology to measure, they use the idea of a hyperbola. One example I've seen is to measure how far away a lightning strike is from two different sensors. I know they use it. But I do have some cool pictures here of hyperbolas. So nuclear towers are hyperbolas, but this is an interesting one that you see in your home when you turn a light on, turn your lamp on. Do you see this is a hyperbola shape, and down here this is a hyperbola shape, okay? So I thought that was interesting. So look at your reference sheet for hyperbolas. Can you figure, I think it's on the back by itself. Does that seem right? It's the one all by itself on one side? Look at that equation at the top. What do you notice? Okay, it's got a transformation left or right on the x with the minus h. It's got a transformation on the y. Okay, but do you see that it always says equals 1? Hyperbolas and ellipses are always going to say equals 1. And the stretch in any direction is going to be the a and the b value. And an ellipse is like a circle that gets stretched more in one direction than the other. And usually we do ellipses before hyperbolas, but I wanted to get this one out of the way when you had time to ask me questions still next week. But we're going to talk about how you draw all this. Now, there's a lot of crazy business on here. The ones you need to be able to tell me are center, vertices, foci, and the equation of the asymptotes. We are not going to worry about transverse axis, conjugate axis, okay? And we're going to introduce C today. So we're going to have A and B and C. And to find C, we're just going to use a squared plus b squared equals c squared. Now, with ellipses, that's a little bit different. What's important about this reference sheet? Is that coming from over there? It's not my computer, right? All right. It says right up here on your reference sheet that a squared is underneath the positive term. Do you see when this one starts with an x minus h, the a squared is under the x term? When it starts with a y minus k, and then back here it's minus x minus h, the a squared is under the y term. Where that a squared is, whether the x is positive, it's going to open around the x-axis, like left and right, okay? When the y is what's out in front and it's positive, it's going to open up and down around the y-axis. Everybody see the difference between those so that you can tell which way it's going to open. All right, so this would be if it was at the origin. It's up to you if you write these down up here, but this would be an x squared is positive because it's opening around the x-axis. Now, the vertices are going to be, let me make mine green. These are vertices, so maybe you can just put a little V by that one. And these points in here are the foci, just like with a parabola, how the focus point was inside, okay? Same idea. And then you know what asymptotes are, right? Lines that it's going to approach. These diagonals are going to be the asymptotes. Now, this rectangle actually has a fancy name. It's called the auxiliary rectangle. If you think I didn't have to look that word up to spell it right. The center is really not going to be part of our hyperbola. The hyperbola itself are just these two lines, guys, these two shapes here and here. All of the rest of this is extra stuff to help us draw it, okay? So the center HK is the midpoint of the foci or the midpoint of the vertices. The vertices or turning points are always A plus or minus A units away from the center. The co-vertices are going to be B units away from the center. The transverse axis, which connects the vertices and has a length of, that would be 2A. And the conjugate has a length of 2B. We're not going to spend a lot of time on that. The asymptotes are the diagonals that guide the curves. The foci are C plus or minus C units away from the center. Now, it gives you a space here to write. How in the world do we find C? Well, it's just A squared plus B squared equals C squared. Now, for an ellipse next week, it's different. It's going to be A squared minus B squared equals C squared, because an ellipse will fall in, the foci fall inside the ellipse. Here, the foci have to be further away so that they're inside the loops of the hyperbola. All right. Oh dear, hang on, let me fix that. What did I just do? Go away, move the whole thing. Okay, I just want to get to my undo button. There we go, moving on. All right, so here's the formulas. Standard form, when it starts with an x that's positive here, and that A squared is under that term, it is going to open left or right. That's the thing you need to know, okay? And the diagonal, or the asymptotes, have the equation y minus k equals plus or minus b over a x minus h. Is that a form that you should know? Does anybody remember what kind of form of a line that is? Should I give you some choices? Standard form, slope-intercept form, point-slope form. Anybody remember? Yeah, it is point-slope form of a line, okay? Y minus y equals the slope x minus x. That's the usual point slope. But we're going to use this x minus h and y minus k. Now, it is different when it opens up down. It's b over a for one of them and a over b for the other. Can I explain why that is? Can you take a second to look up here? Underneath the y is b and a on this one, right? Underneath the x. So slope is change in y over change in x, so it's b over a. Does that make sense? Over here, the a is under the y term, and the b is under the x term. So slope is change in y over change in x, so it's a over b on that one. Now, I'm not going to take your reference sheet away, and as long as you're looking at the reference sheet correctly, you'll be fine. But I just wanted to point out why that is. All right, everybody got what they want written in there? Anybody need me? Okay, so this is our sheet we're going to keep referring to. We're going to go to the next page. This is the back side of the worksheet. All right, so this first one, h and k would be 0 because it just has, if you were writing x minus h squared minus parenthesis y minus k squared equals 1 over a squared and b squared. There is no parentheses up top, so h and k are both 0. Anybody tell me what A and B are? Yep, A squared is 4, so A is 2. B squared is 25, so B is 5. All right, this one has a center. Remember, if H and K are 0, the center is just at 0, 0. So we can just start there. Then what you do is you go out A in the direction, it's underneath the X, so you go in the X direction, A units, which is 2. So we're going to go 2 units this way, 2 units this way. And because the X was the first one, the positive one, in other words, that quantity came first, not after the minus sign, okay? Those are our vertices. So we have plus or minus 2, 0. The covertices, okay, I'm not going to ever ask you about the covertice ordered pairs on this shape. I will on an ellipse, but not on a hyperbola. You just need to be able to draw the rectangle accurately, and it's B up and down. So B was under the Y here on this example, so we're going to go up and down 5. So 1, 2, 3, 4, 5. So it was plus or minus 5 units from the origin. That's all we really cared about. All right, now I want you to draw a little rectangle. I'm going to make mine dotted because it's not actually part of the figure. It's just the guiding lines for the figure. And then we're going to draw in the asymptotes, or the diagonals, sorry. They are the asymptotes, but it's the diagonals from the corner of the rectangle to the corner of the rectangle. All this so that we can then draw in the actual hyperbolas. Now, is this one going at the top of the box or the sides of the box? Anybody catch that? Because the X is first, it's opening around the X-axis, so it's on the sides. Here is one, and here is one. Now, it actually gets closer and closer to the asymptote. My picture is not really very accurate. Mine looks like it's curving away from the asymptote right there. All right. We can actually write the equations of the asymptotes next. Okay, the formula is always y minus k first. Did we have a k here? Equals, plus or minus is the slope, and it's whatever under the y over the x, so it's b over a in this case. So you have to use b and a, not b squared and a squared, so it's 5/2. And then back here, it would be x minus h. Well, there's no h, so it's just x. Does that seem right? They went through the origin, up 5 and over 2, or down 5 and over 2? Seems good. All right, to find the foci, that's when we have to finally do that c squared equals a squared plus b squared. Well, a squared was 4, b was 5, but b squared is 25. So we get c squared is 29. So c is the square root of 29. And it's inside, so it's on the x-axis here. It's c units from the center, okay? Square root of 29, anybody? Five point something. Anybody do it? 5.4. And if you want to just give me the decimal, I don't care. So you would go 1, 2, 3, 1, 2, 3, 4, 5 and a little more. And from the center this way, 1, 2, 3, 4, 5 and a little more. So those are the foci. Anybody have a question so far? A lot of stuff to this. Ready to try another one? Let's do one more that's not got a center somewhere else. So the center's still at the origin, right? This one, though, starts with the y, so it would be y minus k squared minus x minus h squared equals 1, and the a squared and the b squared are always in that order for a hyperbola. All right, so h and k are 0 again. What's a this time, guys? A squared is 36, so a is 6, and b squared is 9, so b is 3. All right. Which way are we going 6, though, from the center? The center is just at 0, 0. So if you're looking at your reference sheet, you should be looking at one that has a y squared first, this guy, right? There's going to be your recipe right there. So the 6, that's the A, is underneath the y, so it's 6 units up and 6 units down. Now, that is actually going to be the vertices because this one is going to open up and down. So we have across 0 and up or down 6. How far are we going to go on the other axis? Anybody know? Underneath the x was a 3 squared, so we're going to go 3. Yep, good job. We're going to go out 3 this way and 3 this way. So that was a plus or minus 3 from the center either way. I don't really care about the ordered pairs for that because you don't actually include those in your graph. It just helps us draw the rectangle. Whoop, 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 whoop. I didn't do that very well. Draw your rectangle and draw the diagonals in. Okay, but where is this going to open this time again? Because the y squared was first out here, it's going to open at the top of our rectangle and the bottom of our rectangle. It does touch the rectangle, includes that one point there, the vertex is at the top and the bottom. All right, let's do the asymptotes since they're already on our picture. It would be y minus k, which in our case was just y, there was no k, plus or minus. Now, is this one a over b or b over a? Anybody looking at their sheet? When it opens up and down, the slope is a over b, because it's what's underneath y and what's underneath x. So a over b is actually 6 over 3. Yeah, if you wrote 6 over 3, I wouldn't count it wrong. This is tricky enough without me getting petty, okay? But 6 over 3 does reduce to 2, and then there is no shift left or right. So it's really just plus or minus 2x. Would that work, guys, if I told you to graph that? Would you go to 0, 0, up 2 over 1, up 2 over 1, or down 2 over 1? That would make those diagonals, right? Checking? Okay. Then we got to do the foci, which is that crazy c thing. C squared equals a squared plus b squared. Well, they gave us a squared and b squared as 36 and 9. That's 45. So c is the square root of 45. If you want to simplify, that's 9 times 5. I'm actually not going to be picky in this unit because if you left it square root of 45 or even the decimal, I'd be okay with it, okay? This is tricky enough without me getting picky. So the picky answer, if I were to write it down, would be 0 plus or minus 3 square roots of 5. Star, did you give me a decimal? Square root of 45 is 6.7. So it went up 1, 2, 3, 4, 5, 6. Ooh, it's just barely inside there. I will tell you this, the closer the focus is to the vertex, the skinnier it is, the skinnier the U's are, okay? Remember the last one, if I go back a slide, do you see this one was quite a ways from the vertex? And so they were much wider loops. That's called the eccentricity. And I don't think we're going to get to that anytime soon. All right. We're going to try one that's not at the center. Can you tell me which way this one's going to open just by looking at it? Yeah, the x is out in front, okay? So it's an x minus h squared over a squared minus y minus k squared over b squared equals 1. It's going to open left and right because it started with the x. All right, tell me something. H is 3, k is -1, a squared is 16, so a is 4. What's underneath this guy back here? Just a 1. So b squared is 1, and the square root of 1 is just 1, so b is just 1 as well. All right, let's actually do all of these by just following the recipe, because I know that's how some of you work, okay? Let me grab my sheet, because otherwise I spend half my time asking you what the recipe is. All right, we're using the recipe for the one that opens left, right, yes? So the center is just HK, which would be 3, -1. The vertices are H plus or minus A, comma K, which would be 3 plus or minus 4, comma -1. On the quiz, I would say you need to write out that that means 7, -1, and it means -1, -1, right? 3 plus 4 is 7, 3 minus 4 is -1. I'm not going to be super picky on your notes, but on a quiz, I want to know that you actually wrote out the ordered pairs. The vertices are B away, so that's going to be plus or minus 1. The foci, it says, are at H plus or minus C, comma K. Let's find C. C squared equals A squared plus B squared. Well, A squared was 16 and B squared was 1. So C is the square root of 17. So if you were writing this for a quiz, you could write 3 plus or minus the square root of 17, comma -1. Can anybody type 3 plus the square root of 17 and somebody type 3 minus the square root of 17? I'm thinking 7.1 or 2 or something. 7.1. And then what's the other one? 3 minus -1.1 maybe? Did anybody do? Yeah, okay. So they're just barely inside of those vertices. The asymptotes are y minus k, which is y plus 1, right? Y minus k, right up there, equals plus or minus. What does the recipe say? Is it A or B over A when it starts with an X? B over A, so that's 1 over 4. And then X minus H, which was X minus 3. And I'm fine with you leaving them like that, okay? Later on, there's going to be some answer keys on some of your practice that have solved for Y. I don't care. Leave them just like that. And my answer keys will always have them left like that. All right. I never do them in this order, by the way. I always draw them first because I do them conceptually. I don't necessarily just follow a recipe, but I wanted to show you that you could, okay? So if I go over to 3, -1, right there is the center. In the X direction, I should be going 4. So that would be 4 left and 4 right. Because that was the number underneath the X, that 16 was 4 each way. The number under the Y was 1. Square root of 1 is 1, so I go up 1 and down 1 from that center. And I draw a very tiny rectangle. And I draw some really tiny little diagonals. And then which way was this guy going? You told me left and right, so it's scrunched in there like this. Okay. Does it make sense that we went up 1 and over 4 for our slope? Okay, that fits our rectangle. Then the only other thing we're supposed to put on here is these foci, but they're just barely inside there. I can't even make it look accurate, so I'm just going to put some dots really close to the vertices. Okay, think you could do this as long as I let you have that sheet? It's just following a recipe. All right, we're going to go to the next sheet. I really don't want to take time for you to write all this down. It will tell you in the directions what to do. If you're confused, I always find the center first, then I draw the rectangle and the diagonals, and then I follow the recipe to write everything down. So if you want to just know the order that I would do things in, I would find the center, draw the rectangle using the A and B, draw in the diagonals, and then follow the recipes. Does that make sense? Everybody got what they want? Like I said, I would not worry about copying all that down, because this part about list vertices, foci, and asymptotes, it's going to tell you that in the directions. Or on the quiz, I will have a blank for those things, okay? Doesn't matter if I tell them not to write it down. Some of them are just furiously scribbling. Anybody need more time? Everybody good? All right. I am going to skip down. Let's just quick sketch number 3. We won't list anything, but can we just sketch number 3? Which way is this one going to go? Because the Y is first, it's going to open up and down. Its center is at 0, 0, and I'm going to go out how much on the Y? 5. Good job. So it'd be up 5 and down 5. And underneath the X is a 16, which means we go 4 either way. Draw that rectangle. And those diagonals, and where are we going to put that bad boy? At the top and the bottom. Those U's are up here and down here. I don't even care about the foci on this one. Do you feel like you kind of get the basic idea now? We're not going to list any of the other fancy stuff. We're just going to sketch it. Okay. Let's do number 4. It wants to come up with the equation. I just want us to see if we have the concept enough to go backwards. Where's the center at, guys? 2, -1. What does that tell us? H and the K. Good job. It's opening which way? Up and down, so it starts with the Y, so it goes Y minus K squared over A squared minus X minus H squared over B squared equals 1. We already know the H and K. We're almost done. Okay, the A is not necessarily the bigger one. It's the one that goes up and down because it's opening up and down. So how far is this up and down from the center? 4. So A is 4, so that's going to be a 16. Yep. Good job. And out in the X direction, it went 3 either way from the center. So B is 3. So under here is going to go a 9. And what goes up top? Y minus plus 1. Yeah, Y minus K. Make sure you do those. It's easy to get the H and K backwards because you're switching where Y and X are, so be careful. And X minus 2 squared here. That wasn't so bad, right? All right. This is just leading us up into completing the square. What does it have to equal? What did I make a big deal at the beginning of the lesson? They always have to equal 1. So what you would do here is you would move the constant to the other side by adding it, right? That would make it positive. But then we'd have to divide everything by what? 324, because it's got to equal 1. Okay, so somebody reduce 9 over 324, or just 324 divided by 9. It goes in how many times? 36 maybe? That's my guess. Okay. And 4 goes into 32 81 times. I can do that one in my head. And then 324 over 321 is 1. So again, on your calculator, for that first one, you can either do 9 over 324 and reduce it, or if you're pretty sure it goes in evenly. So again, it was 9 over 324, math, enter, enter, and that reduced it to 136, or just a 36 in the denominator. Is everybody okay with what I'm talking about there? All right, we're going to try completing the square. We're going to skip to I'd like to try number 12, okay? We're going to skip to number 12, and you will watch a video of some of the rest of this. When I'm gone, I will make a little video for you on writing the equations. Okay. To make this look, which one is positive? Which squared term is positive? The y's, right? So we're actually going to move those out front. 9y squared, what goes with that? Minus 108y. And I'm not even going to bother with the blanks yet, but then it's going to say minus x squared plus 12x, because I'm trying to rearrange so the x's and the y's are together. And I'm going to move the constant to the other side, so it's going to be a subtracted 144. Most common mistake, forget to change the sign when you move that bad boy over there, right? It should come out nice, okay? I didn't give you any where at the very end you have like the bottom is not a perfect square, okay? The denominator should be perfect squares. All right, now we're going to complete the square, but we have to factor out a 9 first. Watch your signs here too. That's going to leave y squared minus, anybody dividing that by 9 for me? I think it's 12. Okay, y, now put your blank in. Okay, take a deep breath, because this is where it gets hairy. We got to take a negative out of these. It's got to say minus. Now, the only thing I'm taking out is a -1, so I'll write the 1 there just to remind you. If I took a -1 out of -1x squared, I'd just have an x squared. But what happens back here when I take out a -1? Minus 12x. Does everybody see what I'm talking about? If I multiplied that back in, it would have to go back to a plus 12x. Everybody good? We're factoring a negative out there. There's a trick to be careful of. Because that won't help us complete the square here in a minute. Yep, that's the issue. Yep. Good question. Yeah, we don't want to take out a -x because then we got to complete the square. All right, so 9 out front. half of the b term, this becomes what? Y minus 6 quantity squared. Squaring the 6 makes this a 36. Now, we talked about this very briefly yesterday. There's a 9 multiplied onto that 36. What I would like you to write on the other side in your notes so that it makes sense to you, will you put in this blank 9 times 36 so you remember where that came from? And then when we type it in, we'll just type plus 9 times 36. All right, then we have a minus 1. And we take half of this minus 12. Remember, it became negative because we took out a negative. So it's a minus 6 again. And so back in this blank goes a 36. But is it a positive 36 when we add it to the other side? It is negative 1 times 36. So we're going to put plus negative 1 times 36. You know what? I think this is going to come out weird. Try this, guys. Negative 144 plus 9 times 36 plus negative 1 times 36. Okay. Oh, that's nice. Okay. I thought it was going to come out negative. And it is possible to come out negative. Then you have to divide everything by a negative. It switches the order around. It's really confusing. I didn't think I put any on here like that. Okay. What do we have to do? Because the last step is it has to equal 1. So we're going to divide everything by 144. And we will be left with, how many times does 9 divide into 144? 16? Is that what you said? What? Okay, it's 1/16, so a 16 in the number. Okay, that's what I thought. Sorry. And this one is just 1 over 144. And an x minus 6. And over here we have 1. All right, we're going to try one more. We can do this. Okay, this time, what's going to be out front? The x's, so we're going to have x squared plus 2x, and then a minus 4y squared and a minus 48y. And on the other side will be a positive 243. Okay, so we put the positive squared term first. And then we grouped the other terms together, right? And set it equal to the constant. Just making some notes about how we're doing this. Okay. Then we do the parentheses and add a blank and all that good stuff. So we're going to do x squared plus 2x plus blank. Oh, by the way, we didn't have to factor anything out this time, right, of the x squareds? But what do we got to factor out back here? So we got to take out a negative 4. So negative 4y squared divided by negative 4 will be positive y squared. Negative 48y divided by negative 4 will be plus 12y. Then we're going to put a plus blank equals 243 plus blank. I got to tell you, I don't know about you on your paper, but this is what I usually end up doing. Are you out of room on your paper? I just write them underneath because I usually don't have room when I'm doing them in my notes. Does that make sense? Just remember that you're adding 2 things onto that side. Okay. Completing this square here, what are we going to get? X plus half of that is 1 squared. What's 1 times 1? It's not 2, it's 1. And there's nothing out in front this time, so we're just adding 1, 1 over to the other side. Just 1 is fine, but I just was reminding myself that I... Okay, then it's minus 4 parenthesis. What does this parenthesis become? Y plus 6. So we are adding in a 36, but it is multiplied by a negative 4 times 36. Okay. 243 plus 1 minus 436s. 144, 240. Is it 100 maybe? Anybody type that and get 100? Okay. So what do we got to divide everything by? 100. Okay, I know what the right side is. It's 1. Does this simplify at all? Nope. So we just have x plus 1 squared over 100. What about this guy? 4 would go into 100. $25 times. So they should be perfect squares on the bottom, okay? It doesn't have to be a perfect square, but I made them so they're all perfect squares so that you know if they're not, that you did something wrong. Does that make sense? Okay, yes. No. For me, I made sure that they all have perfect squares in terms of counting up and down. That is not true for the C value, okay? The focus point can be gross, but I made them all nice otherwise, okay? This is tricky enough without having weird decimals. All right, so tonight, or by Tuesday, please have done 1 through 3 and 5 on worksheet 5. So 4 questions, just 4 questions, okay? And then when we're back on Tuesday, Miss Khan is going to teach you about ellipses, and she has a fun activity to start it out with, okay? It's not something really exciting you guys get to do, but she's going to show you something that's cool. Questions? Enjoy your long weekend, but please get caught up. By the way, I am here tonight if you need to do retakes or get help, and I will be here late on Tuesday for the same purpose, okay? But then I'm gone.